Welcome, everybody. This session is called Moving to Predictive, How to Assemble the Beginnings of Your Feature Store with DBT Labs and Snowflake. My name is Miles Adkins. I'm a senior partner sales engineer covering the AI and ML ecosystem at Snowflake. I'm based out of Chicago. I've been with the company for about 2 years now, and my main job is to really work with Snowflake's partners to do a few things. One, build out the kind of the best, bleeding edge joint product integration. So working with, partners like DBT Labs and a lot of others out there to, how do we best integrate? How do we best push down into Snowflake? Think about security and governance, all in the name of the workload that I focus on, data science, and then also do a bunch of go-to-market as well. So things like sessions like this, webinars, blogs, all that good stuff to evangelize the joint solutions that Snowflake and our partners build and bring to market. The agenda for this session will be first to give you guys kind of a 30,000-foot overview of machine learning. How does machine learning and DBT kind of connect? Where there are some synergies there where DBT can really help with the data science workload. What is a feature store? This is a very new concept to the market, probably 2 to 3 years old. And so as a fanboy of data science and machine learning, this is a concept that I'm very excited about. And then the last 30 minutes or so will be an actual demo of working through a use case using Snowflake, using DBT. How do we wrap all this stuff into a feature store? So with the goal of you being able to really, power ML use cases, not just batch, which DBT might already be used for today, but also more those real-time use cases where, predictions need to be made within milliseconds as opposed to, daily or weekly or monthly and so on. And so with that said, I want to just kick it off here with a very simple graphic of the ML lifecycle for those who might not be familiar. A typical data scientist like myself would, very much just start off doing some problem statement framing. Hey, we've identified a problem in the business that is costing us, hundreds of thousands, maybe millions of dollars a year. It could be in lost revenue through, poorly targeted ads. It could be things like, my machine factory line is producing too many defects. How can we use data to train a model that can then help us make better predictions, whether from a business intelligence perspective or what we like to call in real time, where, we make a correction on the spot. And so a data scientist will go ahead and grab a bunch of data. Usually it's not in kind of picture-perfect format, and so they'll do some data prep. They'll do what we call feature engineering, where they're looking to build kind of valuable signals for a model to catch on to, which will help make the prediction they're looking to make. They'll then go feed that data set into a model. They'll go through many iterations of trying XGBoost, linear regression models, doing deep learning, whatever the use case calls for, to build that actual algorithm that'll help make those predictions for them. And then go ahead and do model deployment, which for the most part, if it's like a AI for BI use case, they're really just going to build a dashboard for a subject matter expert to now, consume and then ideally make better business decisions. What I think a lot of people don't account for in this ML lifecycle is, well, what do I do if it's an AI for operations use case? Again, a model will be going into some sort of application where we might, again, need to make predictions in real time. This is where I think a whole new persona has taken place in the market called an ML engineer. And an ML engineer is much more of a software engineer by trade, starting to use and put ML into production. And so they're going to be focused on a few different types of tasks, things like feature pipelining, Typically, when you go to train a model, your data is already in a data platform like Snowflake. A data scientist will build a bunch of features in SQL or Python in their notebook. It's very hard to port over, that code to a production system application that's probably written in, Java or C++ or, a much more, faster programming language. And so how do we think about taking this work of a data scientist and putting this into our production application? And so that's one thing that they'll do. Another thing is all around model monitoring. So now that we have a model into a system, how do we make sure that it is behaving as intended? There's of course been a lot of stories in the last couple of years on how ML has gone wrong, usually because they didn't fully kind of take into account what that model was really doing. And then obviously the end consumer there is an AI-powered application that the business owner would then care about. And so in this life cycle, where does a technology like dbt labs really come into play? Where dbt is great is specifically in this data prep and feature engineering stage. And so if your organization has already built out a bunch of different data models, there's already great information flowing through from a business intelligence perspective, how can we reuse this same platform that you've already stood up and start to use this for machine learning as well? And so a lot of what a data scientist will do in dbt around testing and documentation, deploying these models into an orchestration tool, dbt is great for that, and they can now leverage this step that you've already set up. Okay, so what is a feature store? So a feature store is a term that originally came out of Uber's engineering group called Michelangelo. And it was really around this concept of, as a data scientist, what I've noticed is I'm always kind of rebuilding and rebuilding and rebuilding all this new code every time that I think of a new use case as a data scientist that I wanted to kind of go after and ideally put into production in the enterprise. How do I think about reducing all of these cycles and giving a data scientist a much more declarative framework where you just define a feature once, you can then put it into this store, and other data scientists in your organization can reuse and reuse and reuse this again, going off of that single standard definition that was originally defined. Another good reason where a feature store kind of came about is this skew between, again, these features that I'm generating in my notebook or in dbt or some sort of code editor, and how do I make it very easily for, once I define it there, moving that same definition to a production system. And so a feature store is going to help us do that as well. And so, so the two fundamental problems are really, how do I have a feature calculated the same way every single time that's accessible to others? A very good responsive data leader will have, as they do their executive meetings and whatnot, is giving their leadership confidence in the data that they're giving to them. And so the more that we can have kind of consistent data across the organization, the better that the better your CDO is going to feel. The second thing is, how do I make sure feature calculations again are used in training are also available at time of prediction? Another way to look at this is kind of a funnel where at the very top you might have a bunch of different data sources that you're working with. And again, as an analytics engineer, data scientist, it's always this process of funneling down all the immense amount of data that you have. And so steps 1, 2, 3, you're really thinking about building those dbt models where you just go from raw data to some sort of entity level data frame that you're looking for. You can think of an entity as what does a single row in that table really represent? That could be a customer, that could be a customer transaction every hour, And so we're always in this process of trying to make our data models have some context to the problem we're trying to solve. And so you can think of kind of 1 through 3, 1 through 4 as this top half of the funnel that we're really going to try to automate and have like a declarative framework to where we can now spend most of our time doing 5, 6, 7, and 8 as opposed to rebuilding this entire use case over and over and over again. It's all about reusability. Okay, so just for some feature store terminology, the two big ones that you'll hear me reference quite frequently throughout the demo here is offline store and online store. An offline store is really the OLAP workload of a traditional data platform like Snowflake, where we're going to do a bunch of generation of things like SQL queries that will get pushed down and doing a lot of the analytic portion of the feature store operation. And then the second piece is the online store, where once we have all of these values that we need to make available for some sort of production application, doing the process of transferring these features into a much faster online cache for low latency feature retrieval. And I'll just give you a second to read through some of these other ones. Okay, and so for the demo, we're going to be looking at a credit card fraud use case. I'm going to walk you through some feature engineering that is actually done within DBT Labs. We will then use Snowflake's new Snowpark feature suite to train a model in our Python UDFs with a open source feature store called Feast. We'll be using this open source project Feast as our proxy for a feature store. There's several other feature stores out there. You can build your own. There's some commercial offerings like Tecton that all work great with Snowflake. And then the last piece will be, how do we think about making these features available within an online serving mechanism, that online store for a much faster production OLTP workload where the model might need to be served and scored in milliseconds. Okay, so moving over to the demo portion here. I'm going to start us out here in a Jupyter notebook. And the main use case that we'll be looking at today, let me make this just a little bit bigger. The main use case that we'll be looking at today is a credit card fraud detection use case where there's a bunch of transactions that are coming through a bunch of different terminals that this company has in the field. And this gives us a few level granularities or ways to look at the data. There's data that's happening specifically per each terminal. There's obviously per each customer that is interacting with the terminal. Or is there just something specific giving the two about the transaction that we can detect that it is possibly fraudulent? And so scrolling down here, I'm just going to do some of my basic imports. I will be using Snowpark as our main method of doing feature engineering. The beauty of Snowpark is you write it in Python, and then all that work is pushed down into Snowflake as opposed to you having to move all that data across the wire into a local environment that might not scale that well. Just going to create a session here. Okay, so looking at some of our initial source data here, I'm going to move us over to our Snowflake terminal and just give you guys a sample snapshot of what this data is going to look like. Let me make this a little bit bigger. Okay, that's not working. Okay. To start off here, we can see that we have a bunch of historical collected transaction IDs with an associated transaction date time. We also know about each row here the customer that this transaction relates to and the terminal where that transaction occurred, along with some other additional information around the transaction amount, the transaction time of days, and then the main thing that we care about is, was this transaction fraudulent or not? And so in this case, we'll be performing a binary classification problem, trying to predict 0, this transaction was not fraudulent, or 1, the transaction was tagged as fraudulent in the system. And so going back to our notebook here, I start to perform some initial feature engineering steps to prepare the data for what I would call a ready-to-model data set. You can see here that I could very well do some of this feature engineering in SQL if I wanted to maintain using Snowflake as my data platform. Or I can now start writing that same code in a client-side Python SDK called Snowpark, and therefore, tailor into a Python developer, and they can start doing the same sort of manipulations to our data as they please. And what I'm going to do here is actually build a few different feature engineering steps that will actually culminate in 3 distinct tables that I'll use. We'll have a transactions and datetime table. We obviously know we have customer information, and so we'll have a customers table. And then we also have a terminal, a bunch of different terminal information where we'll have a specific terminal table. And so if I go to dbt Cloud here, we can actually build all of these specific feature engineering models within dbt. Just looking at our customers.py, obviously in dbt you can now not just build models based off of SQL, you can do so off of Python as well. And so I'm just going to go ahead and do some basic feature engineering steps to get us to a final table. In this case, this specific model will be related to our customers table, and we can see here that our transactions model is actually feeding our customers model. I can go ahead and click dbt run, and this will kick off running. Say that again. Yeah, let me see if let me try it here. Yeah, okay. So this is kicking off here. Let me just pull this down. Yeah, it's not letting me, there we go. Just some standard Snowpark Python functions that I'm performing here in dbt. Oh. There we go. And I'll go ahead and pull up this runs one more time here. And we can see that we have 2 passed, and now we have 1 in the queue. Now, if we go over to our Snowflake terminal and give our query history a refresh, we can see that dbt is now going to push down and compile that Snowpark code that we generated and actually execute that inside of the Snowflake warehouse. And so if we click on our query details, we can actually see that let me grab this guy here. The SQL that is pushed down is this Snowflake customers dbt'd stored procedure. A stored procedure is another type of technical contract that you can run inside of Snowpark. And it's basically allowing you to just set up your own custom Python environment for you to run any sort of Python code that you please. And so we basically bundled up this code here. And the result of these 3 models executing is we can now go to a schema called features. So we had our original raw data in a batch raw schema, we now have a features schema. And we can see that we have 3 different tables that dbt created for us related to the specific features that we want to use for this use case. And so in the case of customers, we now have a bunch of information about, for each specific customer ID, what are some of these, in this case, aggregate rolling metrics that we've calculated that might help us predict fraud in the future. For example, some averages around transaction amount, transaction counts over 30 days, and so on. We also have some features around terminals here. Again, being able to calculate and do aggregates. So think of terminal ID, and then we have things around transaction windows. There's a few more here. Okay, it's not letting me slide. Okay, so moving on here, we've gone through our feature engineering step with dbt, and you can see here that I've generated a bunch of different SQL equivalents of the work that we've performed as well. We did customers, terminals, and did all this in dbt Cloud. All right, so now moving on to the feature store piece of this demo here, how can we think about wrapping something around these, right now, just raw tables inside of Snowflake with a bunch of processed data? We can use our feature store object using Feast as our feature store proxy to put some metadata around these tables that will allow for some sort of Python SDK to much better bubble up things like training data sets and that materialization to an online store that I've mentioned. And so what a feature store really is, and I'm going to pull up some code here, is just a collection of, in this example, .py files that just tell the system, what do these tables and schemas and databases inside of Snowflake really mean. And so using Feast, Feast comes with a Snowflake source Python object. And inside of that Python object, I just basically tell it the path to a specific table that I want to bring into my feature store. I give it an event timestamp as well. This will be important as we think about building point-in-time correct training data sets. I then also will do this for my customers table, as that's the table we want to bring into the feature store. I will also do this for my terminals table. The reason that I left out my transactions table is the transactions table is actually what we call the entity table that we want to build our model on. And so you can think of that table as much more like a list. I give that list to my feature store. It'll give me back a bunch of additional features that live in my customers and terminals tables that allow me to augment my data set. The one other piece here is for each table that we've now pointed our feature store at, we just need to give it an understanding of what does each row in that table really represent. And so for our customer table, we know that each feature within that table relates to a specific customer ID. And so in this case, our join key would be that unique customer ID. For our terminal table, we know that there is a unique terminal ID per each row. We would give that join key equal to terminal ID. And so much like a regular view inside of a data platform, a feature view, as we call it, just culminates a Snowflake source. In this example, we have customer source and its associated entity customer and builds a feature view that now allows it to understand what are all the different features that live within that table that I can now bubble up to our end feature store consumers. And so much like a feature view is really just a bunch of metadata that lives on top of those raw physical tables. And I'll go ahead and do the same thing for terminals as well, and create a terminal feature view. And you can see here a list of the different features that we will now have that are going to fill and live within our feature store. And so from here, all I need to do is go to my terminal and run a quick operation called feast apply. And so again, this is just a collection of .py files. These live within a feature store folder, which you could upload to GitHub, do a bunch of CI/CD for going from a test environment, a sandbox, to a production feature store. The one other file that we need for our feature store is the infrastructure.yaml file. Obviously, feature stores are agnostic to their underlying infrastructure. And so for this example, we're going to be using Snowflake as the single dedicated engine for all of the feature store operations. And you can see here that I'm basically telling it to take my Snowflake context and use that as our infrastructure decision. And if we go back to our terminal here, we can see that we've applied changes, and we've gone ahead and deployed infrastructure for both our terminal and customer feature views, which tells us that our feature store is now ready to have you call it for those features that were uploaded. So going back to our notebook, I'm now, again, going to kind of put on that hat of a data scientist. I'm now a feature store consumer. And if I'm an ML platform team, a group of ML engineers, and I want to kind of enforce, you using Snowflake, for example, as your data platform, I can still have you use Snowflake without you even really recognizing it by, again, giving you a feature store layer to work with. So putting on that data science consumer hat, just like you would in a typical notebook, we can create and instantiate a feature store object. For our use case, we can then request a list of features that we want to use and train our model on. And so as opposed to having just a bunch of blocks of SQL that you generate your features with, the feature store gives you that declarative framework for you to just give it a list of features that you want to retrieve and fetch to augment your entity data frame with. And so what this looks like at the very end here is I go ahead and build that shopping list. In this case, it will be a pandas data frame with the transactions that I want to use in my model training process. I have customer ID, I have terminal ID. Here's a few of the features that I have out of the box. We know that we're looking to predict fraud. And I simply feed this original Python data frame along with my features list into a function called get historical features. And in a very declarative fashion, we will now go ahead and generate a point-in-time correct training data set. Point-in-time correct meaning we're trying to just get rid of any sort of target leakage that we might have. And we will go ahead and land that exhaust table inside of our Snowflake training schema. And so if you go back to our query history here, we can see that Snowflake has gone ahead and built, this is kind of tough to see here, built this big, long, point-in-time correct training data set query for us kind of out of the box. And so again, making this super easy for data scientists to not have to worry about doing this, just giving them APIs that will do this automatically for them. And the result is a training data set that has all of our original inputs from that data frame going up to fraud, plus all of our customer-specific features, as well as our terminal-specific features. And what's really happening behind the scenes here is our feature store is able to understand, now that you've given it these specific join keys, customer ID, terminal IDs, and join those features from those other tables into our main spine table. And so from here, we can take a snapshot. Here it is, again, just in the pandas data frame format. Okay, so now we're actually ready to just train a model. We have our data set, and we can start training our model. I'm going to show you a specific way of actually training your model inside of Snowflake as well. And so instead of you doing this on a Jupyter notebook, again, you run out of memory. It's not very scalable. We can actually now train models inside of Snowflake as well through Snowpark using, again, the same thing. dbt uses Python stored procedures. And so you can see here that I basically give it a Snowflake a DDL command called, in this case, train model 4, where I go ahead and do your very simple model building steps. Create your X, your features. What is your Y? What is your target that you're trying to predict? Go ahead and train a random forest classifier and give me the output, give me those model artifacts, and save those into a Snowflake stage. And so I will go ahead and run this guy. Here is my list of input features that I want to use. And I can now call this stored procedure right from my notebook and go ahead and train the model. And so this takes just roughly about 20 seconds here. Again, we can go back to our query history. And see that this is all getting pushed down into Snowflake. And so then the last piece here is now we want to be able to take our model and really do two things. We want to be able to obviously just, for that AI for BI use case, take your model, make some predictions, and serve that up as potentially a dashboard. We can go ahead and retrieve that model from Snowflake. So again, that model artifact lived inside of a Snowflake stage in the cloud. We can now bring that local to potentially do some model assessment like feature importance, standard steps that data scientists might do. Looks like we're just taking a second here to grab this from the cloud. Not sure what's going on there. Okay, so the last piece is we'll just assume that we're happy with the performance of our model. We understand what are the main features that are driving the predictions, and we've been given the thumbs up to go to deployment. If you wanted to use this model as again, AI for BI use case, you could just score this, put this into an Airflow operator with the latest and greatest data that's coming out of your DBT models. That's well within scope of a data scientist to do so and serve that up to end consumers. If you wanted to take this model and actually put it into a real-time, for example, fraud detection application that might be living on the terminal itself, that would be very hard for a data scientist to figure out. And so what he can do, now that we have this feature store construct living within the organization, is just tell an ML engineer, here's the model that I want to deploy, and here is the list of features that I trained that model on in our feature store, and that's pretty much it. What a ML engineer can do from here is focus on the deployment side, and all he has to do is basically ensure that the features that were used are now available on a much faster, low latency online cache. And so what he can do, and if we go to our last schema here called inference, he can set up these online inference tables that for Snowflake are now what we call hybrid tables, which go after the OLTP workload, which have a much faster response time and lower serving latency, and start actually serving up these features in real time. And so these tables right now are actually empty, right? We've done no command to move our data into these tables yet. If we go over to a terminal, and you can really think of me working in a terminal as synonymous to, just an Airflow orchestrator, running some sort of bash command. We can do the same thing with our materialization code, these processes of moving data from offline store to online store, and run those. And so we're going to say, give me the current time of right now, and I want to run this command, feast materialize incremental, and this says move the latest values for each unique pair of customer ID and terminal ID, and make those available for real-time ML in the case that at any point in time, one of those specific combinations is looking to make a transaction. And on the spot, we can then predict if it might be fraudulent or not. And so we can see here that this materialize incremental command generated a Snowflake query per each feature view that we have, so two queries in total. Again, pushing this all down to Snowflake. Snowflake will do the merge command from offline to online. And at the very end here, we can now feed that ML engineer that got these artifacts from the data scientist. They can take that features Python list artifact, and that's all they need to give to our second most important function, the get online features function, and very rapidly get back a sample of features that might be used in real time. And so, for example, I just generated a bunch of random combinations of customer IDs and terminal IDs to mimic possible users logging into a transaction system at a given point in time. And what we get back is that unique list of features that our model can now ingest and make a prediction on. And so then the last piece here would be to actually score that model. And so we can see, in addition to our input features, we can run a predict probability function, And what we get back is a probability that a specific transaction that we've scored is fraudulent or not. And so we can see some are 36%, 98%, and so on. And so that sums up the demo portion of the session here. So just to recap, we kind of went through what are some of the advantages of using DBT with Snowflake and how to do that for the ML workload. How do you think about taking some of that DBT models that you've already stood up and not just servicing BI, but also ML? We walked through what is a feature store, how a feature store can help you be more productive as a data scientist in a data scientist enterprise, and then walk through the demo. And so with that, I will take any questions. Go ahead.
Are you able to group different feature stores into, say if there's several different teams and each team has different types of metrics and stuff, they might want an easier way to find their features. Is there a way to group them?
Yeah. So within each feature view, you can think of that as a specific group. And so if you wanted to have, you might have multiple different analytics teams, data science teams, right? Some groups might have special privileges to data that others do not if you're in a protected industry. And so the beauty is a feature store actually will inherit all of the security and governance that you've set up in Snowflake. So all of that role-based access control just gets inherited. And what you can do from there is just, again, set up specific feature groups related to a specific team or domain, and only they would get access to what you've propagated up to them.
The most important question on Slack is, are you going to be able to share the notebook?
Yeah. So the notebook is actually already out there. It's a little different than what I showed you today. This was tailored towards introducing DBT as your feature engineering pipeline. But if you just Google Snowflake and Feast, you will see a lot of this code that I've already walked through out there.
The second question on Slack was, the tables you were materializing in Snowflake, are those tables or are those views?
So the tables that we materialized in Snowflake for that low latency retrieval are actual physical tables. The difference between those tables and the other tables that we looked at originally that had our raw data is they're actually hybrid tables, which is a private preview table type in Snowflake that we announced back in June at Snowflake Summit. And the characteristics of those tables are supposed to be lower latency serving. So as opposed to it taking a couple hundred milliseconds to get those values back, we're targeting the kind of less than 100 milliseconds P99, as well as a much higher queries per second. And so as opposed to our warehouses today, you might throw a couple queries per second at it. These hybrid tables will actually allow you to send upwards of 10,000 queries per second and still perform at those low latency numbers. Go ahead.
Is there a way to measure model performance?
Yeah. So the good thing is model performance is actually one layer higher than a feature store. So the way that we think about it here at Snowflake is at the very bottom, you just have your raw data. The next layer is just putting some metadata around that data, i.e. featureizing it, making it those features. Now, it doesn't matter if you train a linear regression model, an XGBoost model, a deep learning model. All of that kind of comes after the fact once you have your feature layer, operating the way you want it to. And so we call this, a model operations would be next, where you care about model performance, model monitoring, interpretability, all that good stuff. All right. Well, with that, I appreciate the time. And let me know if there's any other questions. I will be happy to stick around and enjoy the rest of the conference.